In this video, we look at the domain of a rational function. The domain of a rational function includes all real numbers except for the values of x that make the denominator 0. So that's a really big thing. The idea is that you cannot divide by 0, and so any values that make the denominator equal to 0 will not be valid numbers to plug into your equation. So in our practice problem, it says find all values of x that are not in the domain of h of x. Not in the domain. And so what we want to do is we want to focus on the denominator. So our denominator is x squared minus 49. So what I want to do is actually set this equal to 0. I'll do x squared minus 49 equals 0. And I want to solve that. So you can solve it by factoring or using the square root method. I could go ahead and say this is the same as x squared equals 49. And when I take the square root of both sides, I have to remember to do plus or minus. So x equals plus or minus square root of 49. So x equals plus or minus 7. The square root of 49 is 7. So all the values of x that are not in the domain of this rational function, I would answer x equals -7 and x equals +7 are not in the domain. Are not in the domain of h of x. So that would be my answer. Now, all the other real numbers would be in the domain. So in the next example that you're going to see, we're going to list the domain in interval notation. And so we would use all the real numbers except the two values that we found. We want to find the domain of the function f of x equals x minus 9 over x squared minus 17x plus 72, and write your answer as an interval or union of intervals. Now, this is often the part that people have problems with. So what I'm going to do, just like before, I focus on the denominator. And what I want to do is I want to set that equal to 0. So I'll have x squared minus 17x plus 72 equals 0. And I want to go ahead and factor this so that I can solve. So I want two factors of 72 that add up to be -17. So it would have to be a negative times a negative in order to multiply to be a positive and add to be a negative. So let's think about this. I know that 9 times 8 equals 72. So if I did a -9 and a -8, that would multiply to be 72 positive, and then it would add to be a -17. So I'm going to go ahead and use x minus 9 times x minus 8 equals 0. And if you recall from the previous homework where you had to solve these, you'll use the 0 factor property. So we get x minus 9 equals 0, add 9 to both sides, and we get x equals 9. And the second factor gives us x minus 8 equals 0, add 8 to both sides, and we get x equals 8. So x equals 9 and x equals 8. These are our two numbers that are not in the domain. So our domain is going to be all real numbers except for those two. And normally for all real numbers, you would have negative infinity to positive infinity. So what we have to do is we have to start with a negative infinity, and we have to somehow exclude these two numbers. Now you want to take the one that comes first, the smaller one, and put that one in your first interval. So negative infinity to 8. To exclude 8, I'm going to put a parenthesis. Remember, if I have a parenthesis, that means that that number is not included. And we don't want to include it because it's not in the domain. And then it says a union of intervals. So I'm going to go ahead and do the union symbol. I don't want to forget the interval between these two values, 8 to 9, 8 to 9. And then I don't want to forget the 9 to infinity part. So basically what I did was I broke this up into 3 intervals, negative infinity to positive 8. I use a parenthesis to exclude the 8. I want to do 8 to 9, but I use parentheses to exclude those endpoints of 8 and 9. And then I do 9 to infinity, but I use parentheses to exclude the 9. So first, set your denominator equal to 0. Those will give you, and solve it, and those x values will not be in your domain. And then you break up your intervals between negative infinity and positive infinity, but with these endpoints that you found here not included by using parentheses.